Hi, folks. Thanks for coming, especially at 4:20. I know this is probably the last session, and my feet are tired. I'm sure yours are. I'm Jeff Needham from Travelers Insurance. I'm a senior architect. I've been with Travelers, the business insurance division, for about 10 years.
Hey, good afternoon. My name is Mike Braasch. I'm a second vice president with Travelers. I lead a program of 13 cross-functional or Agile teams, and we're accountable for building and maintaining applications that support our underwriting capabilities. So before we get started, just a couple quick things about Travelers Insurance. For those that don't know, we are the Red Umbrella Company. This morning, Dave said we were 150 years old. He cheated us out of 10 years. No. We're actually 160 years old. We are the only property and casualty insurance company on the Dow Jones. We have over 30,000 employees and close to 14,000 independent agents and brokers. We do business in the United States, Canada, Ireland, the UK, and Brazil. We're basically three main components: personal insurance, claims, and business insurance. And Jeff and I represent business insurance, and that's our largest portfolio and definitely our most diverse. And so just kind of continuing the theme from this morning, we are also hiring skilled engineers. Check out our website or speak to me after. I have extra drink tickets.
Thanks, Mike. We really are hiring, by the way. So we take innovation pretty seriously, and like Dave said this morning, like it's not an industry known for innovation. So I think, especially for us in insurance, it's something that we've been focusing on pretty heavily over the last few years, and it's so important to us that our CEO Alan Schnitzer has posed to us this challenge, and this comes right from our 2016 public report. So we want to leverage new technology, we want to redesign the way that we manufacture and sell our products, and we want to anticipate how our future customers will interact with us. And we don't want to react, we want to be actually ahead of the curve on a lot of this stuff. And so if you believe what we believe, if I weave baskets and Mike weaves baskets, and I have really great ones and his are pretty mediocre, but he's got the software to sell them online, and he's got the software to create, customers and put marketing material out there, and he's going to sell a whole lot more baskets than me. So software is really the differentiator. Those of us in this room, we run the world, whether we realize it or not, but the world runs on software now. So if you believe that, well then, engineering and developer productivity is paramount. These are the two most important skills in business today. You can be innovative with your products, you can weave great baskets, but at some point you need developers to get that stuff to market for you. So if we want to be innovative, then really all of us in this room and all of us in this industry, we're at the front lines of the innovation. You can have the ideas guys come up with new product ideas, but we're the ones that are actually facing the legacy, facing the challenges of getting that stuff really delivered and executing on these ideas. So what we believe in Travelers and what we believe in our shop is that if this is all the case, then we can't just sit idly by. And if chance favors the prepared, we have to act. We have to do some things that maybe we don't absolutely have to right now, but we have to put ourselves out there and take some risks and some chances if we want to be innovative and if we want to sell more products and be ahead of the curve and not reacting.
I didn't know where you were going with the basket weaving deal.
My baskets are better, but
I see that. Yeah, I noticed that yours were better.
Yeah.
Okay, that's good. So, so for us, the software delivery challenge was pretty clear. So how do we significantly increase or reduce the time from business ask to production? So how do we go from concept to cash, or said differently, how do we go from an idea or vision to working tested software? So we were asked to go faster, but keep quality high. We were asked to go faster, but we weren't given any more money. So I'm assuming this is a challenge that you guys face in your companies as well. So for us, getting to the heart, next slide there. Getting to the heart of our content here today. We're here basically just to share our story about the things we've done, the disruptions that we've introduced in response to that software delivery challenge. So we've transformed our people, we've transformed our processes, and we've transformed our technology. And for us, really, the database was kind of that final piece. And so in the end, this is a story about why we think the database is such an important part of meeting that goal and meeting that challenge of time. So we were tasked with building a single point of entry for our account executives and account managers to manage their book of business. Previous to our application, our users would have to log into up to a dozen different applications to kind of get the full picture of their work and see the full breadth and depth of their accounts. So we set out to simplify and modernize the technical landscape and build a new distributed web-based architecture. So in 2012, we struggled. We actually didn't build anything that we could move to production. So we had a couple different fits and starts. We were going to do a big waterfall project, and then we were going to do a big agile project. And we were going to be multiple teams, and then we were going to be a single team. And at the end, we didn't build anything. So we said in 2013 that we needed to do something different, and we implemented Scaled Agile Framework. So we adopted an agile mindset and agile practices, agile processes, and we knew that part of that disruption needed to be our people as well, and so our culture needed to change as well. And we'll get into more of that in a bit.
So Mike's not kidding when he said we struggled in 2012. And for those of you that work in older companies or larger companies, this picture should look pretty familiar. You've got all these front ends, you've got all these software components in the middle, and there's this labyrinth of databases behind the covers, and they're all kind of commingled into this web. So for us, the challenge was really how do we simplify this legacy landscape and build something nice and clean in the distributed space. So iteration one, or release one, really, this first release was we built a bunch of ETL jobs, and we copied the information from the legacy databases into one new operational data store, and we were able to build this nice, clean, single application that our users could log into. And so you really would have to log into 12 different systems to see your book of business as an account executive. Some of the policies are here, some of them are administered here. You know, in a 160-year-old company, we've got a handful of systems that we've acquired or built over the years. So what we did is we built an operational data store.
Not all of our systems were 160 years old, but it felt like it.
Yeah, some of them are half, some of them are a quarter.
Right. Yeah, absolutely. So at the end of 2014, we had built what we set out to build. So we had a single simplified view of the business for our end users, eliminating that need to log into multiple applications. We built RESTful services with HTTP endpoints, and we were a program of agile cross-functional DBT teams, define, build, test teams, working from a single backlog that was prioritized by our product council, which is made up of product owners and product managers. So we were really starting to gain some traction in 2014. But we're entirely dependent on ETL. Our application was slowly becoming a monolithic web of service calls into a single database. And at the end of 2014, our business partners asked us to start introducing transactions. And so that brought on a whole new host of integration concerns for us.
So Mike, we've done some great things. We went from this web in the legacy landscape to a nice single clean distributed application. We adopted the Scaled Agile framework. We've got a product council making decisions now on what features and what requirements we build and what we release. We must be off to the races, right? We must be saving a lot of time right now.
Yeah, you know, at this point we had improved. We were consistently deploying 5 times a year to production, which for us was a major increase. And our application was getting not only like extremely high response from our users, but it was one of our most performant applications in the entire portfolio. So we were really starting to build something that our users like, but we recognized that there was still a lot more room for improvement.
So the first thing that we did, I think, after we built this nice operational data store, is we decided to move to microservices. You know, we had a WAS infrastructure, and like Mike said, it was I've got a policy screen, an account screen, and I've got these tables under the covers. And it didn't take long, like a couple of years, your service-oriented architecture turns into a spider web of, you know, I've got 5 services that call the same table. So, and then one schema change ripples through all those 5 services that you've got to refactor and add that new column into. So we moved to the microservice landscape, and we said, well, let's chop up our services. Let's leave the database alone. Let's leave the tables alone for now. And let's do the poor man's microservice database-wise. Let's just give the service table exclusivity. So the policy tables were only accessed by the policy service.
Can you use that mic? Is that one's feedbacking?
Oh, yeah, sure.
Yeah.
Hello? So the policy service talks to the policy table, but if the account service wants policy information, it doesn't go to the policy table anymore. Right? So we have table exclusivity. And then we also said, well, you know what? Let's point our ETL jobs to bulk endpoints. So let's not have the ETL jobs write to the tables in bulk anymore. And then we also built our own change data capture framework that emits deltas from our host applications. So in almost near real time, like 5 seconds, you transact in legacy. We've got the information now in our microservice and in our database. And so what this gives us is this service at the center, this kind of all-seeing, all-knowing entity that no matter what you do, if you read or write information, or no matter who you are, the microservice is aware. So, and I can do some pretty neat things now on the right-hand side. I can do eventing now. The microservice can not only write into its own data store, but it can now emit an event and broadcast those changes to whomever in the landscape needs to be aware of those changes. So we use Kafka for that. We've got other microservice subscribers that want to be kept whole with our deltas from one service. And we even keep our data warehouse and our data lake whole by this eventing framework. And so it's not just one microservice. We have about 130 right now.
Close to it.
So
now, fast forward between 2014 and 2017, we continued to introduce these disruptions, and we really started to apply a lean product mindset. And we started working towards these goals that you see across the top. And we knew that in order to achieve those goals, we had to align our technical value stream with our business value stream. And so that we knew it would take a lot of effort in the different categories along the bottom in order to meet those goals. So for us, it started with the business, and we adopted domain-driven development and really made sure that we were talking the same language, which was the language of the business. The second piece was the architecture. So Jeff talked about the microservices, which was obviously key, but beyond that, we adopted and started to implement micro front-ends and event and API-driven architecture. So development, we really kind of stole from Amazon and said, if you build it, you run it. If you build it, you own it. And so there was the ownership and accountability by the teams. Started to develop some expertise, and they really did take ownership of their code. Plus, if you call them at 2 in the morning, they get really upset, and so they fix everything so they don't have to do that again. So from a testing perspective, a pretty common refrain, everybody's looking to automate testing, but we really had a laser focus on that to say, any test that we build, how do we automate this? From a DevOps perspective, we started looking at building out a self-service continuous delivery pipeline with an ultimate goal of getting to continuous deployment. So we've achieved some level of success with that, which has been great to enable us to deploy small chunks of code, so thereby mitigating risk, and it also facilitates that fast feedback loop, so drives into our product council of what we're going to build next. And then the last piece was the ProdOps piece. So if we're going to say, hey, you build it, you run it, we have to give them the right visibility and the right tools to do that. So we changed how we did our monitoring and alerting.
So this is some significant change.
Yeah.
Scaled Agile framework, modernized legacy. We rewrote our modernized legacy into microservices. We've got continuous delivery. We must be flying. We must be able to go from concept to production in days now, Mike.
Yeah, not quite. No. But we definitely had made some significant improvements. I mean, the fact that we were even doing some level of continuous delivery was pretty crazy. In fact, we would do presentations internally, and I think people thought we were lying. So we literally would have to deploy code to show them that we were actually doing that inside the walls at Travelers. So, but here, we kind of stopped and assessed where we were at. So we liked the gains that we had so far. We liked that we were able to stand up services very quickly. And we knew that we still had some more opportunity. And so really we started to focus on the database layer. And we said, what are the people, processes, and technologies around our database? And we knew that it was time for an agile transformation there. And so we made arguably one of our biggest disruptors, and that was the move away from the relational database.
So to keep things safe inside our shop and to keep the powers that be at bay and not stopping us, we said we were going to run an experiment, and we were going to do it on something small that wasn't tremendously financially impactful. But when you think about it, it's pretty important. So we decided to use MongoDB for our prospect application, and that's really identifying and managing sales leads, prospective customers. And we had a basic challenge of unifying a handful of existing legacy systems and creating a single set of data and common definitions and a single source of truth. So our first release was great. We had some screens, we had some business concepts. and we had a database. And I didn't show the tables and columns. The table names are the columns, but you can kind of get the picture here. If you're doing it right, you got more than a couple tables for even a really simple set of use cases. So who would prefer not to develop against this many database objects, right? I think probably most of us, right? So this is release 1. Great. And then our business folks were like, you know what? We got to rethink this whole application. We got to rethink the business and how we track sales leads. Excellent, because in the scaled agile framework, this is failing fast, right? So
Learning fast.
Learning fast, right? So this is a good thing, except if you're the relational database and you're the developer that's got to rewrite the ORM layer. So this was release 2. Way better. So this was the point, I think, where we were kind of, a couple things happened and converged at this moment, where we rewrote the application, we incurred this pain, and we have a backlog, so we kind of know what's coming down the pike a few weeks ahead of the release. And there was another change coming in. It was just like, oh my God, are we going to rewrite this thing a third time? And this was a fairly minor business change, but it was a nuance that was going to break a couple of these tables. And then the other thing that happened in our shop was we've got one database, a bunch of tables, a bunch of services, and I need to add one column. And this is not a joke. This is one column to one table for one service. The other 19 were not impacted. And DBA is like, well, you got to bring all the services down. And we're like, we got continuous delivery. We've done all this great stuff. Like, we're deploying multiple times a week. Like, what do you mean we got to bring all the services down for one table, one column change? Well, we back the database up before we make the structure change. Because, in the event that something goes wrong, I need a restore point to restore the database. And when I back the database up, I kill the connections because I can't have deltas flowing in while I'm backing the thing up. And it was like, oh, man. So it was a moment of frustration for us. So this was like, you know what? We're going to use MongoDB. We're going to use this application. We're not going to rewrite it a third time in Oracle. And we're going to use this as the inception of a different database, because this truly was the last Agile frontier, or last frontier of Agile transformation. We've done all these great things, and here we are in this database where we're waiting around days for table changes to be made. So we had good rationale for change, and this was, and this is the moment, I think, where it's pretty important. Like, we want to relate to everybody in this room that may be in this same position. So this was the management speak. This was the kind of information that we provided to our higher-ups. We're like techies, we're developers, we're architects, so we were like, yeah, let's use MongoDB. We know this is the right choice. We're frustrated with Oracle, but we've got layers upon layers of risk-averse folks in insurance. It's their job to be risk-averse and manage risk. So we've got to give them some logical rationale. And I'm sharing this because I think that it really is true. But you do need to have some polish, and you do need to kind of walk talk the right talk. So there's a relational Agile mismatch. We're doing all these things in Agile. We're delivering minimal viable product, one release to the next. And that means I'm delivering small increments. I don't know the full end picture. Maybe the business doesn't either. But the relational database design really kind of wants you to have that stuff all mapped out and designed right up front. And if you don't, and if you have a breaking change or you add stuff that you didn't predict from day one, you actually might incur a lot of database changes on your second and third release, and then ORM layer changes and a lot of programming. And then simple one-to-many relationships. This was my favorite. It's like, if I have a customer with 3 addresses, I'm never querying that address information outside of the context of a customer. Why does that have to be a separate database object? And this was maybe a little bit harder sell to our management, but I try to express to them, this is what you get with relational. If you're doing it right, you're casting your repeating groups out into separate objects. But that's problematic for our developers. And remember, like, if software is the differentiator, if our CEO wants us to innovate and be ahead of the curve and not reactive, and if all of that, and if developer productivity is key, well, I'm losing developer productivity on this kind of stuff with a simple one-to-many relationships if I'm doing it right with my expensive relational database platform. So there's this ORM object relational mismatch. And then another thing, we started to do machine learning. we started to talk about innovation in terms of where does the insurance industry go? Can I put a sensor in a shipping container and track this information and as the insurer shave off potential liability and loss and then offer that as a value-add service to the customer, which is a mutually beneficial thing. But that's a lot of information. We know this is an industry that's used to 20 use cases, and there's 20 tables, and there's one system, and it's been the same for the last 20 years. And now there's this flood of information. There's this. It used to be data at rest, and now it's really data in motion, but it's really data at consumption. There's all these different consumers of this information. So really for us, relational was the bedrock of our organization. And I think for us, this is where I want to talk about the practice changes that we made in information architecture to make sure our powers that be were okay with this change. Because you could easily let your development crew run off and build things in MongoDB, and your last 20 years of good database design with good names and data types and all these standards are suddenly now thrown to the wind in the matter of 6 months, and you've got sprawl everywhere. So it's not really a problem, but these things could happen, and these are the kind of things our higher-ups kind of were worried about. So we brought in data modeling tools. We bought Accolade, which is a phenomenal product. You should definitely be using that to model your JSON schemas. We talked about names. We decided we weren't going to truncate and use those crazy truncated names anymore. And in 3 months of using, full-on product identifier instead of prod_ID and these crazy truncated names, in 3 months of using that, it's you cannot go back to those old names. But we were diligent, though. We said we are going to have names. We're going to use class words. We're going to do data modeling. And then I think on the technical side, let me go back one more, actually. So there's one other change, though, I think that was really significant. And, in a database release or in any kind of software release, there's not all technical folks along for the ride. You've got developers, but you've got business analysts, you've got product owners, and you've got actual business folks. I can write code, but if that code isn't meeting the business requirement, or if it's not really meeting the essence of the business strategy, then you're writing the wrong code. So I think in any kind of software release, you want to make sure that your analysts, your QA people, all have a chance to be in this game together. And I think with the rise of NoSQL databases, it was sort of this developer landscape that said, we're just going to take the database over. And it started to push some of the more functional folks out. But you absolutely need those kind of folks along for the ride. You want them to be fluent in the JSON modeling structure, and they can be. Like if you look at Cassandra or Couchbase or Hadoop, it's this weird blend of JSON and SQL, and it's not nearly as friendly. So we taught our BA folks and our QA folks how to read and write data in MongoDB because we wanted them along for the ride. And then the technical impacts here, your architect is absolutely your most important developer advocate. So you need somebody fielding questions. You need somebody figuring out the hard stuff in your release for your development team, especially if MongoDB is new. You need one point person to be the one that figures the stuff out for your development team. And I'm going to move actually past this slide because this is the kind of the good stuff here is. So I had a lot of tables in my first release. We had a lot of tables in our second release. And in our third release, when all is said and done and we built our application against MongoDB, I've got 2 database objects. So, and then 90% of the functionality is in the second one. So it's kind of one, really. And all these one-to-manys are in that second object. But as a program, I can just go and get one object from the database, and I can parse through it in memory. I don't have to do 10 joins.
Right. And kind of playing off that theme of efficiency on the next slide there, these are just a couple pictures of code snippets. And obviously the one on the left is against our relational model, and same API with the one on the right is with Mongo. And so I was speaking with one of our engineers, and I was just asking him just in general, I said, What's your experience? How do you like working with Mongo? And he said, I feel like 3/4 of my job has been eliminated because I don't have to do the data mapping. I don't have to do all that I used to do. And I thought, well, geez, I hope he's not doing that for 3/4 of his job. But the point is that It's a significant amount of time. It's a significant amount of time saving of not having to do that tedious task. And now he can work on higher priority items. He can work on some other innovation items. And this is a common and consistent refrain from all of the engineers across the program.
Yeah, so if you're doing it right in relational, you have a lot of tables. And if you're modeling it properly, you have a lot of objects, even for simple use cases. And this was actually the APIs from one release to the next, from Oracle to MongoDB. That's one sample API. We sanitized it so you can't really read it. It's too blurry, but our legal folks were happy with that.
Yeah. Super important.
And one is Oracle and one is MongoDB. We won't give away which one is which. So, in this theme of innovation, it's not an easy undertaking, especially when it comes to the database. So we used our experiment, and we cut over from Oracle APIs to MongoDB, and we added new functionality in 8 weeks, and we came in under time and under budget. And we think there's probably a 75% increase in developer productivity that went along with that. But being an insurance company, you put a number out there, people really want to see how you quantified that. So we made that a little bit safer, but it's definitely significant. I mean, even if it's 20%, we'll take it. We want to shave off config. We moved to containerized development, and we moved away from WAS so we could stand up a service. A developer could stand up a service in a half a day instead of 5 days. Why wouldn't we do the same thing with the database? So we think we have a significant increase in developer productivity just by not having to write an ORM, just by not have to deal with this 20-table model that I showed you before. And some of these APIs went down from 1,000 lines to about 300 lines. Existing APIs, the same functionality from Oracle to MongoDB. So I think really here, and the theme for us is really, if we're doing this right with relational, we're burning a lot of cycles when we probably don't need to be. And we've done a lot of things in our shop to try to become faster. And if the database was slowing us down, well, then that database needed to change. So I think we kind of met our goal, Mike. Right? Finally, when all was said and done, I think we finally found that moment of all these things that we did and brought in. We finally met this goal of let's get concept to production in the shortest amount of time possible. And these are just some basic stats. It's kind of not fair because we were kind of ramping up as a program, but in 2013 we had 40 tables in Oracle. We had 70 in 2015. We had 100 in 2017, so pretty slow growth. But then in the last year that we put 2 collections, we really, in July of last year, when we were here at MongoDB, we were about 4 weeks away from deploying our first 2 collections into production. And well, right now we've got about 120 with probably another 50 in the wings for the next release or 2. And we've got about 10 million documents a day that we write into them. So it's just, for us, it's actually been quite a surprise how fast we've been able to come up to speed with the database and how much we've been able to move to MongoDB in such a short amount of time. And it really tells us that this surge of database structures is proof that we're building more widgets. They're not baskets, but they're widgets.
Correct. So really the culmination is just our overall transformation. So now we're working, one team can own all of their dependencies, minimizing any handoffs with external teams, increasing that speed. We have a single pipeline for our deployment, including the database objects. Really, deployment it can be as short as of just a few minutes. And for us, all new work now starts with MongoDB. And you heard Jeff, if you attended the keynote this morning, his favorite new line is JSON is the new SQL. And really for us, there's no going back.
Absolutely. We're still in pursuit of this goal, though.
Correct.
Right?
Correct.
We're still not
right.
Still not completely happy. We're Agile zealots, but that's fine. But we really have shaved a lot of time off, and JSON is the new SQL. Absolutely.
Any questions?
How did you get rid of the ETLs?
We built our own change data capture framework. We used IMS exit routines and host DB2 triggers that when you insert into the legacy databases, either the exit routine in IMS or the DB2 trigger will emit a delta into MQ. And then our microservice wakes up and reads that MQ message and does a SQL select and gets the full record from the host and puts it in our database. So that's how we do source data replication, source to target replication now. So Yep.
Original model that you converted to microservices. You said that my table structures changed to the two objects. Did every microservice share that single, those two objects?
That's a good point. So,
Good question.
That's not the main point. It's the question how what experience.
no, but that's a point I actually wanted to mention. So we said that we'll give our microservices table exclusivity. The book says that you should give them database exclusivity, right? So the microservice owns its own database. So we didn't really want to incur the cost of standing up more Oracle instances. So we left them all in one instance, but we gave exclusivity to the service. And so we said when we moved to MongoDB, that was the time when we decided let's give the microservice its own database. So that prospect service and its prospect database, no one else touches that. So
Correct.
correct.
Yep.
So the 120 that you stood up,
Slowly. Yep. Slowly cutting over. Yep.
Yeah, and we've got about 50 MongoDB databases in production, and they're all specific to a particular service, particular microservice.
So similar to how we've done really all these different disruptions, and we start very small and very slow, right? And so there's not a, Mongo cutover initiative, right? Because no one's going to fund that. But as we go over, we look at and say, okay, well, is now a good time for either standing up something new or a cutover for something? And it's those kind of small experiments.
Go ahead. Yeah, go ahead.
so have you done anything different since the first kind of cutover to where now you've got your 120 coming up? Are you doing anything different?
With the database?
In your experience with setting up the services and the databases, is there anything that you've learned that says, hey, you know what, we didn't do it right the first time?
Not on the service side. I mean, we have a blend. I think we did start to move to Node.js big time. We started to say no more Java, no more .NET services. Let's try to build as much as we can in Node where possible because it's just such a lighter weight programming language. So.
I think going into it, we knew it was going to add in a bunch of complexity, right? And I think we knew that, but I don't think we took it as serious as we should have. So when we had 4 microservices, it was cute, right? And now that we have 120, I mean, we have a display up in one of our rooms. It's kind of like shows the application and the traffic. And it's complex. It's very complex, and so making sure that we know kind of who's accountable for what, because it really starts to grow, and we're adding more and more every release. So going in with that complexity, I think that's something that looking back, like I said, I think we paid maybe just a little bit of lip service to it, but certainly that's something that now we're a lot more cognizant of. Absolutely, yeah. Yep.
Hey, thanks. Great presentation.
Appreciate it.
So it sounds like some of your services, like each one has a few collections that they own within like their context boundary.
Right.
In the diagram, you show like how you integrated some message bus,
Yep.
maybe to share context across those boundaries.
Yep.
Does that mean that like each of your services, maybe you have 2 types of services, one that's actually serving requests and one that's maybe just tailing that log and writing into one of those like 3 collections, say that they have?
Right. Well, we try to not tail the log. We try not to use that. We try to actually make the microservice. You write 1,000 policies into me, I'll write 1,000 deltas into Kafka. Mm-hmm. Some of those messages could be big, so it's prohibitive to put the entire message body, the entire record into Kafka. So I'll just put the keys. And then you as the account service that need to be aware of those changes, you would come and read the keys from Kafka, and then you would call the endpoint, and you would get the full attribution by just calling the endpoint with those IDs.
Gotcha.
Yep.
So you're not like necessarily updating the state of some of the entities in your collection based off some of the other services events?
No, we are doing that now where we have to transact back to the host. We're like, let's just capture this information. Let's transact and create a new account in this new distributed world. But let's go to our antique IMS-based application and actually create the account. So, because all these reporting engines run off this old system. So we do have to actually do some kind of, it's this change data integration we're calling it now, where like I just create the account in the distributed, and then I post it to the legacy system. And if there's a failure there, well then I can come back and mark the record suspect in the distributed app, and that's all done asynchronously.
Thanks.
Next question.
Hi. What were some of the changes in people and culture that you made in order to make the transition into Mongo?
How much time do you have?
Yeah. People love SQL. And people that are, I think, to be fair, there's a spectrum of skills when it comes to management. People Mike's only a 2 VP, so maybe VP level positions, people
Not
that really
VP
can
enough.
get in your way. There's a spectrum of skills, from functional to technical, and we all fall somewhere in the middle. And I think that the key for us was finding the folks in management that had that technical proficiency, that we could say, hey, look, this database is terrible. We got to get rid of Oracle. We got to go to MongoDB. And they're like, yeah, we get it. Okay, can you now go sell that to the more functional managers, the more cautiously optimistic, they need to be convinced from more business rationale that this is a good thing. So we really had to sell this as, look, it's developer productivity. If you want to innovate, if you want to get your stuff to market quicker, this all comes down to cost. And if I'm paying this much for an RDBMS and I'm paying this much for the other database, but it takes me this much time to go to market with this expensive database, and it takes me this much time to go to market with this database, it just becomes really a cost argument. So it's really been that, finding those leaders on the technical side that are trusted and respected, that can kind of bring it down or bring it up a level, right? To bring it up to a functional level.
At the end of the day, it's really about change management, right? Because we had a lot of processes and practices that involved a bunch of handoffs to centralized data teams and DBAs that did stuff. And a lot of those practices we didn't need anymore. So that was scary to folks, right? We were kind of altering their job description. So a lot of folks had some concern there. So that's something that actually we still struggle with today, to make sure that we need our people, their skills, and our processes to evolve. But it really just comes down to change management and showcasing that, hey, this is a better, more efficient process, and we'll kind of figure out the rest as we go. Mm-hmm.
Hi, one follow-up question.
Sure.
You have these legacy systems that are still on RDBMS. How do you handle the schema changes that are pushed to you from them? Because you have to now modify your collections.
So like deltas in the legacy?
Well, let's say your legacy system added a new column in their table, and now they're pushing that data to you, right? So you have to refresh your collections.
So the advantage of the microservice is that it's not bound by schema. It's bound by service contract. So I can decide that I want to bring in more fields in legacy, and with MongoDB, if I have like 2 or 3 levels, or I have another level I need to add, I'm really doing that logical modeling, that entity and attribute modeling inside a single document. So the likelihood of me needing a breaking schema change in MongoDB, it doesn't happen anymore. So if I have new structure in legacy, or new fields in legacy that I want to bring in, it's probably going to fit into my existing documents. The likelihood of you needing to add a whole nother collection into your MongoDB to account for a handful of attributes in legacy, it's almost the other way around now, right? Because you can handle so much attribution and so many one-to-manys and one-to-ones and embedded one-to-manys inside a single document now. You can do everything that you can do in relational in MongoDB, and so much more, and all that more, you can't do any of that stuff in relational.
Yes, I agree that, but my point is, a lot of times when you are extracting data from legacy systems, right, which I'm considering probably some authoritative systems, like a billing system, if there are additional attributes added for a customer, and you want that data in your MongoDB so that you can serve the data for your front-end applications.
Sure.
We have that pattern a lot because our business goes directly to the billing system. They talk, I need you to add all this stuff, and then they come and tell us, hey, go get all that data, I want this to be served. So if you are doing this, you would always be facing the situation where you have to extract new data into your collections. So do you have to write some kind of data repair programs that you will constantly have to do, or?
Or if you want to add like new fields to existing
Yeah, new
documents.
fields to your existing collections, because
No, you just do an upsert. It's awesome. You just do an upsert.
Okay.
And the fields that don't exist, just get added on insert or update to the existing documents. You don't, like you would have to normally with an Oracle, you gotta do a structure, an unload, a structure change,
Right.
data manipulation, and then a reload. With MongoDB, you can really write just a program with your existing legacy data and insert just the new fields that you want added to the existing documents.
Okay.
Yeah.
Gotcha. Thank you.
Yep.
Hi. I got a question on the data modeling stuff. How do you store all the policy information, or how about the claims? Do you store in the MongoDB as well?
What's the first type of information?
Like, do you store
Policy?
policies and claims and billings?
Yeah, absolutely.
Okay.
Yeah.
Like, say, in terms of a policy transactions,
Yep.
do you store all the data related to that transaction, or you just append to the policy level? Like, say you have a policy, and then all the changes, and then the delta in between. So,
Yeah, like
how do you store it?
Well, you have to think about unbounded growth, I guess. Like if you have a root level policy and you've got transactions now you want to add to it, you know, it's not the document size is quite small for a lot of volume of transactions, believe it or not. So we would embed that as an embedded relationship. We wouldn't cast it out into a separate collection. That's what, in fact, that's exactly what we do. We have like, you know, maybe 1,000 transactions or a couple thousand transactions on one policy. And if you're using JSON, as long as you don't put XML in there, I mean, your documents are going to still be kilobytes, hundreds of kilobytes, nowhere even near a megabyte in size. I mean, really, the megabyte document is massive in JSON. So you can have like 10,000 transactions on your policy and keep it all in one document. We store the whole thing. We got a whole rating audit now for policies in MongoDB. So the entire rating event and all the rating variables are in another collection. Everything.
So thanks so much, guys. That's all we have time for today. I know the conversation is still going.
Thank you. Thanks, guys.
So hang out here and ask some questions afterwards.